Dear students, Namaste, good morning to you all, and also welcome to another session of online mathematics class. In today's session, we will discuss a new chapter, that is chapter number 4, Determinants. Let's move on to the introduction. Take a look at the system of linear equations. L1x plus m1y is equal to P and L2x plus m2y is equal to Q. This system of equations can have the unique solution, no solution, or infinitely many solutions. Let's discuss the case of the system has unique solution. Means the condition is L1 by L2 not equal to M1 divided by M2. The given system of linear equations can have unique solution if L1M2 minus L2M1 not equal to 0. This inequality is derived from this statement. Now we have learned that the given system of linear equations can be expressed in the form of a matrix. That is, matrix L1M1 L2M2 into matrix XY is equal to matrix PQ. Means in the first matrix, that is a 2 by 2 matrix, we have to write the coefficients of the variables x and y, L1, M1, L2, M2. These are the coefficients of variables x and y. And in the second column matrix, we have to write the variables, that is x and y. And on the right side of the matrix equation, we have to write a column matrix which contains the constants. Now, consider the 2 by 2 matrix L1, M1, L2, M2, that is this matrix. The real number L1, M2 minus L2, M1, which is associated with the matrix L1, M1, L2, M2, can be obtained by multiplying the diagonal elements and then subtracting the products. Means you have to multiply the diagonal elements L1 and M2, L2 and M1. You have to multiply it and you have to subtract it. And you will get a real number. And this real number, how we are getting, in the sense we are getting it from this matrix, this 2 by 2 matrix. So this real number, that is called the determinant of the matrix L1, M1, L2, M2. The real number what we get is L1, M2 minus L2, M1. So today in this session we shall discuss more in detail about the topic determinants. Let's define determinant in terms of functions. Consider two sets. Set A is equal to set of square matrices. B is equal to union of real or complex numbers. Let a function f from a to b defined by f of x is equal to b such that x belongs to A. A means set of square matrices, and b belongs to capital B. This capital B is the union of real or complex numbers. Then f of x is called the determinant of x. In little more simple way, if we explain the determinant, it is a function whose domain is the set of all square matrices and codomain is the union of real and complex numbers. Once again, determinant is a function whose domain is the set of square matrices and codomain is the set of real or complex numbers. It is denoted by determinant A or det A and read as determinant of A. If A is equal to matrix A1, B1, A2, B2, then determinant A or det A is equal to A1, B1, A2, B2. How we have to write the determinant? In the sense, just to draw two parallel lines and put the elements of the matrix inside, that is A1, B1, A2, B2, and this is called the determinant of the matrix A here. Please note that the determinant of A is not the modulus of A, even though it looks like a modulus, but it is not modulus. It is read it as determinant of A, and determinant X is only for square matrices. Let's discuss how to find the value of determinants up to order 3. A determinant of order 1 by 1 matrix A is equal to matrix A11 of order 1 by 1 is given by determinant A11 equal to A11. Means here there is only one element in the matrix A11. That element itself is the value of the determinant. Next, in the case of a 2 by 2 matrix, A is equal to A11, A12, A21, A22 is given by, we have discussed in the previous case, that is determinant A is equal to just multiply the diagonal elements and subtract it. That is A11 into A22 minus A12 into A21. That is the value of the determinant of order 2 by 2 matrix. And in case of a 3 by 3 matrix, A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 is given by determinant of A is equal to just draw two lines and fill up the elements from the matrix A11 to A13 and A21 to A23, A31 to A33. And this determinant can be expanded in 6 different ways. Means we can expand along first row, we can expand along second row, we can expand along third row, likewise first column, second column and third column. 6 different ways we can expand. So we shall discuss some 2-3 cases. First we have to go expansion along the first row R1. That is determinant of A is equal to, we have to start with a minus 1 the whole power 1 plus 1. So first row, in the sense we have to go like this, 1 plus 1, first element is A11 into that particular column and row we have to remove. A11 I am taking, and this 1 and this 1 we have to put it as a power of minus 1. Then that column and that row we have to eliminate, and the balance is this one, A22, A23, A32, A33. That we have to write it as a determinant. Plus, next we are going with the A12 element we are taking. A12 if you take, it will be minus 1 the whole power 1 plus 2. Minus 1 the whole power 1 plus 2 into A12 into that A12's row and column we have to eliminate. This row and this column we have to eliminate. Balance is A21, A23, A31, A33. That it is written here. Plus the last element is A13. So minus 1 the whole power 1 plus 3 into A13 into that row and that column is eliminated. The balance is A21, A22, A31, A32. That is the way we have to write. Therefore, determinant A is equal to minus 1 the whole power 1 plus 1. That is minus 1 the whole square. Minus 1 the whole square is plus 1. So no need to write. A11 into this 2 by 2 determinant, we know how to expand it. Diagonal wise we have to multiply and we have to subtract. A22 into A33 minus A32 into A23. Here second element if you take, minus 1 the whole power 1 plus 2. 1 plus 2 is 3. Minus 1 the whole power 3 is minus 1. So this plus into minus 1 becomes minus. A12 into, again here diagonal we have to multiply, A21 into A33 minus A31 into A23. That is what it is written here. And next element minus 1 the whole power 1 plus 3. 1 plus 3 is 4. Minus 1 the whole power 4 is plus 1. Plus into plus is plus. A13 it is written here. Diagonal elements you have to multiply, A21 into A32. Next minus A31 into A22. So that is the expansion of this determinant. Next, in the case of finding the value of determinants of order 3, we shall discuss how to expand along row 2. So let us take the determinant. Determinant A is equal to A11 to A13, A21 to A23, A31 to A33. So here we are going to expand along this row, second row. Then as before, we have to start determinant A is equal to minus 1. We have to start with the minus 1. We are starting with the second row, second row first element, that is 2 1. A21 the element we are taking. So minus 1 the whole power 2 plus 1, that is written here, into A21 into that particular row and column we have to leave. So balance is A12, A13, A32, A33. This is the determinant element. Plus second element we have to take A22. A22 means minus 1 the whole power 2 plus 2. Minus 1 the whole power 2 plus 2 into A22 into we have written, then that particular column and row we have to leave. So balance is A11, A13, A31, A33, that is written here, plus last element is A23. So minus 1 the whole power 2 plus 3 we have to add into A23 into that row column is left, balance A11, A12, A31, A32, that is what it is written. Now we have to expand it. Minus 1 the whole power 3 is minus 1. So minus 1 into A21 is minus A21 into diagonal elements you have to multiply A1 into A33 minus A32 into A13. Here minus 1 the whole power 2 plus 2. 2 plus 2 is 4. So minus 1 becomes plus 1. So plus A22 into diagonal elements A11, A33 into A31 into A13 it is written. Plus minus 1 the whole power 5. So it is an odd number, so we have to go minus 1 the whole power 5 is minus 1 itself, minus A23 into A11, A32 diagonal elements A31, A12 we have to multiply. So that is the way we have to multiply along with the row, second row. Next we have to go how to expand along with the first column. First column means this is the one, first column, how we have to expand along first column. Determinant A is equal to, we are going to expand it with this column. As before, determinant A is equal to A11 element we have to take, that means minus 1 the whole power 1 plus 1. That row column is gone, balance A22, A23, A32, A33 it's written, plus second element is A21. A21 if you take minus 1 the whole power 2 plus 1, okay, into determinant A21 element, that particular row and column is gone, that is A12, A13, A32, A33 is the balance, plus last element is A31. If you take A31 minus 1 the whole power 3 plus 1, that is written, into A31 into row column is gone, balance A12, A13, A22, A23 it's written here. Then we have to expand as before, A11 into A22, A33 minus A23, A32 minus A21 into A12, A33 minus A13, A32 plus A31 into A12, A23 minus A13, A22. That is the expansion of the given matrix of order 3 by 3 along the first column. While explaining how to find the value of a 3 by 3 determinant, I have told you that we can expand it in 6 different ways because there are 3 rows and 3 columns. Here, please note some points. For easier calculations, we shall expand the determinant along that row or column which contains maximum number of zeros. Means you have to analyze your question of means a 3 by 3 determinant if it is given, means first you have to analyze the determinant and you have to choose the number of rows or columns which contains the maximum number of zeros, and using that column or row you have to expand it. Next, while expanding, instead of multiplying minus 1 the whole power I plus j, the previous examples and all we have seen that minus 1 whole power 1 plus 1, 1 plus 2 and all we have substituted there. So instead of writing minus 1 the whole power I plus j in each and every step, we can multiply plus 1 or minus 1 according as I plus j as even or odd. For example, if you are starting with A21, A21 means 2 and 1, second row, first column. So 2 and 1, if you add 2 plus 1, 3 you will get. 3 is an odd number, so you can just multiply minus 1. And if you start with A22, 2 plus 2 is 4. 4 is an even number, so you can just multiply plus 1. That's all. Next, consider an example here. Let A is equal to, there is a matrix 2, 2, 4, 0 and B is equal to matrix 1, 1, 2, 0. Just analyze A and B. It is clearly visible there that A is equal to 2 into B. A is equal to 2 into B. If you multiply 2 here, 2 into 1, 2, again 2 into 1, 2, 2 into 2, 4, 2 into 0, 0, that is a matrix here. So A is equal to 2B. Next, determinant A, if you calculate, just multiply the diagonal elements. 2 into 0 minus 4 into 2 is 8. So that is equal to minus 8 we have got. And the determinant B, if you calculate, 1 into 0 is 0, 2 into 1 is minus 2. That is equal to minus 2 we have got. Means determinant A is equal to minus 8 we have got. Minus 8 we can split as 4 into minus 2. And this 4 we can split as, or we can write as 2 square. So 2 square into this minus 2. Minus 2 is our determinant B. So we have got a relation. Determinant A is equal to 2 square into determinant B. Means, in general, determinant A is equal to 2 power n into determinant of B. And in general, if you write, if A is equal to KB, where A and B are square matrices of order n, then determinant A is equal to K power n into determinant B, where n is equal to the natural numbers 1, 2, 3, etc. Once again, if A is equal to KB, means as here we have mentioned A is equal to 2B. Same way, if A is equal to KB, where A and B are square matrices of order 1, then determinant A can be written as K power n. K is the element or number which we multiply with the matrix B. K into n. N is the order of the matrix. Into determinant B, where n is equal to 1, 2, 3, etc. This is the result. Next, we have to solve some questions from the exercise. Evaluate following determinants in exercise 1 and 2. First question is determinant 2, 4, minus 5, minus 1. It is a 2 by 2 determinant. We have to calculate the value. This is simply multiply the diagonal elements and subtract it. 2 into minus 1 minus 5 into 4. So 2 into minus 1 is minus 2, minus 4 into minus 5 is plus 20. So 20 minus 2, that is equal to 18 is the answer. Second question, first part, determinant cos theta minus sin theta cos theta. For calculating the value, multiply the diagonal elements and subtract it. Cos theta into cos theta minus sin theta into sin theta. Calculation, cos theta into cos theta is cos square theta, minus is plus, sin theta into sin theta is sin square theta. So cos square theta plus sin square theta is 1. Second question, determinant x square minus x plus 1, x minus 1, x plus 1, x plus 1. So expand it along the diagonal. X square minus x plus 1 into x plus 1 minus x plus 1 into x minus 1. Remove the bracket. X square into x, that is x cube. Then x into x, that is minus x into x, that is x square. 1 into x, that is x. X square into 1, that is x square. Minus x into 1, that is minus x. 1 into 1, that is 1. Minus a minus b, a plus b form, that is a square minus b square. X square minus 1 square is 1. Then here when you check, minus x square plus x square cancelled, plus x minus x cancelled. So the balance is x cube plus 1 minus x square plus 1. We have to remove this bracket, minus x square plus 1. So just arrange it, that is x cube minus x square, then this plus 1 and plus 1 we will get it as plus 2. Now move on to question number 3. if A is equal to matrix 1, 2, 4, 2, then show that determinant 2A is equal to 4 into determinant A. So first of all, we have to write the given matrix A, that is equal to 1, 2, 4, 2. Then we have to calculate 2A because we need here 2A. So just to multiply 2 in along with A, that is 2 into 1 is 2, 2 into 2 that is equal to 4, 2 into 4 that is 8, 2 into 2 we will get it as 4. Then determinant of 2A we have to calculate, that is our LHS part. Determinant of 2A, matrix 2A is here, then we have to calculate the determinant, that is 2, 4, 8, 4, it is written. 2 by 2 determinant, easy to calculate. 2 into 4 that is 8 minus 8 into 4 that is equal to 32. So 8 minus 32 is minus 24 is the answer. That is the left hand side. Now move on to the right hand side, that is 4 into determinant A, that is equal to 4 into determinant A, matrix A is here 1, 2, 4, 2. From there we will be forming determinant A, that is 1, 2, 4, 2 determinant. Then 4 into diagonal elements multiply, that is 1 into 2 minus 4 into 2. So that is equal to 2 into 2 minus 8. 2 minus 8 is minus 6. 6 into 4 minus 6 into 4 that is equal to minus 24. So when you see the left hand side and right hand side, both are getting minus 24. So finally we can conclude that left hand side is equal to right hand side. Now we shall move on to question number 4. If A is equal to matrix 1, 0, 1, 0, 1, 2, 0, 0, 4, then show that determinant 3A is equal to 27 into determinant A. First of all, we have to write the given matrix, that is A is equal to 1, 0, 1, 0, 1, 2, 0, 0, 4. And when you see this matrix, first column and the third row, the number of zeros, two number of zeros are there. Here 1 0, here 1 0 in C1, and in R3, first element is 0, second element also 0. Means when you expand the determinant along C1 or R3, that will be easy for us to calculate. So here I am going to use C1, I am going to expand the determinant through C1. So when I expand it, determinant A is equal to, first element is 1, I have taken 1, A11, A11 in the sense first row, first element, so 1, 1, 1 plus 1 is equal to 2, 2 is an even number, because of that this is a positive. So 1 into that row and column is gone, 1, 2, 0, 4 is the balance. Next element is 0, that is second row, first element, 2, 1. 2, 1 means 2 plus 1, that is equal to 3. 3 is odd, because of that it is minus. Minus 0 into that row, column is gone, balance 0, 1, 0, 4, that is written here. Next third element, that is 0, that is third row, first element, that is 3, 1. 3 plus 1 is 4. So 4 is an even number, because of that the sign is positive. 0 into that row, column is gone, 0, 1, 1, 2 is the balance, it is written. Then expand it, 1 into first this diagonal, if you multiply 1 into 4 minus 2 into 0, that is 0, minus 0 into any quantity is 0, plus 0 into any quantity is 0, the final answer is 4 we have got. Then 27 into determinant A, when you calculate 27 into 4, that is equal to 108. Label it as equation number 1. Next we have to calculate 3A, because we need to determinant 3A. For that we calculated 3A first, that is 3 into matrix A is written, then take 3 inside. When you multiply 3 inside, you will get the resultant matrix here. Next what you have to do, determinant 3A we have to calculate. Determinant 3A in the sense, here also I am going to expand it through C1. So 3 into first element is 3, so first element means 1 1 1 1 1 plus 1 is 2, 2 is even, because of that positive element, that is 3. Row column is gone, that is 3 6 0 12, balance it is written. Next is second element, second row, first element, that is 2 plus 1 3, 3 is odd, because of that it is negative sign. 0 into row, column is gone, that is 0 3 0 12, it is written. Next element is 0 here, that is third row, first element, that is 3 plus 1 is 4. 4 is an even number, because of that it is plus. 0 into row, column is gone, that is 0 3 3 6, it is written here. When you expand it, that is 3 into 12, that is 36. 0 into 6, that is 0. These two terms will go to, when you multiply with 0, these two terms will change as zeros. So finally 3 into 36, we will get the answer as 108. When you look at equation number 1 and 2, we can come to the conclusion that LHS and RHS are equal, that is determinant 3a is equal to 27 into determinant a, hence the proof. Now move on to question number 5. Evaluate the determinants. First one is a 3 by 3 determinant, that is 3 minus 1 minus 2 0 0 minus 1 3 minus 5 0. So it is, when you observe that the second row is having more number of zeros here, 0 0 minus 1. So it can be observed that in the second row the two entries are 0. So because of that we have to expand along the second row. That will be easy for us. Then so let us take it as determinant A. Determinant A is equal to, first element is 0. 0 means this second row first element. Second row first element means 2 and 1. 2 plus 1 is 3. 3 is an odd number. Because of that we have to put minus 0 into row, column is gone, balance minus 1 minus 2 minus 5 0. It is written here. Next we have to go this element, means second row second element, 2 plus 2. 2 plus 2 is 4. 4 is an even number, so the sign is plus. 0 into row, column is gone, 3 minus 2 3 0. It is written here. Next third element, that is minus 1. Minus 1 means second row third element. Second row third element means 2 plus 3. 2 plus 3 is 5. 5 is an odd number, so sign is minus. Minus, then this minus 1 we have to put, minus 1 into row, column is gone, balance 3 minus 1 3 minus 5. It is written here. So for the calculation, that is, this is 0, this is 0, no need to bother. Then here minus into minus plus, this is minus into minus plus, 3 into minus 5, that is minus 15, minus 1 into 3, minus plus. So minus 15 plus 3, minus 15 plus 3 is equal to minus 12. That is the answer. Now we have question number 2, question number 3 and question number 4 here. So these 3 questions you will do it as homework. Next move on to question number 6. If A is equal to matrix 1 1 minus 2, 2 1 minus 3, 5 4 minus 1, find determinant A. So this question also you will do it as homework. Next we have to move on to question number 7. Find the value of x if first part is determinant 2 4 2 1 is equal to determinant 2x 4 6x. So just to go for the calculation, that is given equation as it is we have written. Next go for finding the values. Is a 2 by 2 determinant, easy for us to calculate. Diagonal elements we have to multiply and subtract. 2 into 1 2, then 5 into 4 it is written, equal to 2x into x is written, minus 6 into 4 is calculated. Next go for calculation. 2 into 1 that is equal to 2, 5 into 4 is equal to 20, equal to 2x into x is 2x square, minus 6 into 4 is 24. Then 2x square is equal to, this minus 24 we can bring to the left side. So 2 minus 20 plus 24. When you do the calculation you will get it as 6. So x square is equal to 6 by 2, that is equal to 3. Then x we will get as plus or minus root 3. That is the value of x in the first part. Now move on to the second part, that is determinant 2 3 4 5 equal to determinant x 3 2x 5. As before we have to go for finding out the value, that is 2 into 5 minus 4 into 3 equal to x into 5 minus 3 into 2x is written. Calculation. 2 into 5 is 10, 3 into 4 is equal to 12, equal to 5 into x is 5x, minus 3 into 2x minus 6x. Then 10 minus 12 that is equal to minus 2, 5x minus 6x equal to minus x. Minus minus cancelled, finally we will get x is 2. Move on to the last question of the exercise. If Determinant x to 18x equal to determinant 6 to 18 6. Then x is equal to, there are 4 options given to you, 6, plus or minus 6, minus 6 and 0. So we have to find out which is the correct answer. Go for the calculation. Given statement it is written x to 18x is equal to 6 to 18 6. Evaluate it, just x into x, that is x square, 18 into 2, that is equal to minus 36, equal to 6 into 6, that is 36, minus 18 into 2, that is equal to 36. Then x square minus 36 equal to 36 minus 36 is 0. That is x square is equal to 36. That is x means plus or minus 6. So plus or minus 6 means the correct answer is B. So B we have to mark. Dear students, today we have learned the basic concepts of determinants, and also we have solved the first exercise from the chapter Determinants. And here you have to take utmost care when you expand a third order determinant, where we have to keep the minus sign and where we have to keep the plus sign. So please go through the video, and if you feel any inconvenience or doubts, please feel free to ask. Thank you for watching.